Can anybody tell me what geometry means? What's geometry? Is it just angles? Angles, lines, points. What about them? Different shapes. Here, let me give you guys a definition. Here's a definition of geometry. The branch of mathematics concerned with the properties of and relationships between points, lines, planes, and figures. That's what geometry is. So it's part of mathematics, and there's some different properties. Now, properties mean like laws, postulates. That's what we mean by properties, that show the relationships between points, lines, planes, and figures. Now, on a plane is like a flat surface that extends indefinitely in all directions, represented by a parallelogram. But you can think of a plane as just like space here in the air, like a flat space in the air. But in order to work inside the plane, we have to draw it, to illustrate a drawing of it, okay? And many of the things that we're going to do are two-dimensional, but when you get into volume, you're going to have a few three-dimensional things. So most of the stuff we're going to talk about is two-dimensional, but we will have some situations where things are three-dimensional, okay? So you'll notice as I'm going through these definitions, if you will look in your study guide, page 2, page 3, page 4, and the first exercises, activities on page 5, deal with some definitions in geometry. So you're going to want to read along with page 2, 3, and 4 and make sure you understand these definitions. Okay? So as I'm doing this PowerPoint, I will put the video up, but you're going to want to follow along and write any extra definitions that you want on these 3 pages at the beginning of your packet. So a point is a location in space that has no size. It is named by a capital letter. So here's the point A. And just like I said, you can just draw a little plane and put a point and a line in different shapes there. For illustration, we have to have some sort of flat surface to deal with the two-dimensional figure. When you read it, you're going to say the point A, because you have to learn how to read in geometry too. It has its own language. We would just write it as a big A. Now, a line is a series of points that extend in 2 opposing directions without end. So notice that this end has an arrow, meaning that it continues on, and this one has an arrow as well, that means it continues on. So this goes into infinity. But I can call this a particular line because I have a point Q on it and a point S. I can read this line 2 different ways. I can say, this is the line QS, Q to S, or this is the line SQ, S to Q, because it goes on infinitely on both sides. So the line QS or the line SQ. We would write it like this. Notice that I'm writing it with 2 arrows on the top to show that it's a line that does not end. You need to illustrate that too when you're notating the line. Or you could write it as SQ with a never-ending line. So we could read this 2 different ways in geometry. A line segment is part of a line with 2 endpoints. Remember, segments stop. They do not go on forever. So at point B, this line segment stops. At point R, this line segment stops. So the way that we would read it is we would say the segment RB or the segment BR, whichever way you want to label it. And when we write it as an ending line, no arrows on the end. So the line RB or the line segment RB, the line segment BR. You have no arrows there that indicates it ends, and so it's a segment. Then we have some other special lines which are called rays. A ray consists of one endpoint at the points of a line on the other side of the endpoint. So notice, this has got an ending endpoint at C, but at D it continues on forever. You can only write this ray one way because it continues at D. So you will write it and read it as the ray CD. You can't say DC. And the order does matter. You have to say CD and then make it look like a ray. Endpoint and never ending end. So a ray has an endpoint and then an arrow on the end. And it can only be written one way. The endpoint comes first, and then the never ending portion comes second. You have to write it in that way. So let's quickly review the terms that we've talked about. These are the ones that are going to be talked about a lot today because this is the intro to geometry, but we're going to focus on lines and angles in our first couple of lessons. A point, the result of an intersection of two lines represented by a dot in the plane. A line is a figure formed by connecting 2 points and extending beyond each point in both directions, represented by the arrows at each end. So looking down here, where is my line? Do I have a line? There's a line down here? No, remember a line has 2 arrows at the end. I don't have one. I have an array, which makes an angle. I have a ray here, the ray AB. I have the plane point W, and I have a line segment, but there's no line here. So you might want to draw a line and make sure that it has arrows on both ends. A line segment is 2 endpoints, so we can say the line segment ST or the line segment TS. So here's an illustration of a line. Then a ray is a line starting at an endpoint and extending indefinitely in one direction. So this would be the ray AB. The ray AB. Okay? K is a point and W is the plane. But I did not give you an illustration of a line here. You can draw your own line. You can call it AB and have 2 arrows on both ends of it. Here's some more terms. Now, when we talk about an angle consists of 2 rays with one common endpoint. And this is an example of an angle. Here's the endpoint. So you have from this point to that arrow, that's a ray. From this point to that arrow, that's a ray. Now, this point where the 2 rays meet is called the vertex. The vertex. Vertex is going to be a very important point in geometry because you create angles that way. Now, a vertex is a fancy name for angle. 2 rays or lines that have the same endpoint make a vertex. So if I have a square, because a square is created with 4 different lines, then I have 4 different vertices. 1 here, 1 here, 1 here, and 1 here. There's a vertex at every angle or every corner of the square. Likewise, if I have two crossing lines that are perpendicular, that means they're 90-degree angles, they're straight up and down or straight left and right, vertical and horizontal, then I've also created four vertices. I have one here, one here, one here, and one here. So crossing lines create angles, and certain figures create angles. Now, when I talk about certain figures, we're going to talk about some special figures. We're going to talk about open and closed figures. All of these properties in geometry that we're talking about are going to deal with closed figures. So you see this triangle here that is created by 1, 2, 3 rays? Well, I can have some properties regarding this closed figure with the lines. But when you have a line that's just going any old kind of way and there's no organization to it, this is called an open figure. There's no postulates for that. I just think of this as like a little scribble. We can't have any rules and regulations for this little scribble, but we do have rules and regulations for actual shapes that are formed with lines and angles. Now, going to those shapes, you can have a closed shape, but the closed shape has to deal with line segments. So we got a line segment here for this triangle, just like the one we had in the prior slide. And we had one for this square, where all these lines are connected. And then this has 1, 2, 3, 4, 5, 6. What kind of polygon is that with 6 sides? What's it called? 6 is what? What prefix for 6? Say it. What did you say? No, not hexagon. Not sexagon. Hexagon. H-E-X. Hex is 6. Okay. What would one with 8 sides be? No, it's not eightagon. What is it called? What kind of polygon is it? Polygons are usually named by their sides because the sides are usually equal. Unless it's a rectangle or something. What prefix means 8? Okay, what animal has 8 legs? What animal in the sea has 8 legs? Yeah, so octopus starts with oc. O-C-O. So oc means 8. So it would be an octagon. Okay, what about 5 sides? You guys need to learn your prefixes. What is this one called right here? Okay, so what's the prefix for 3? Tri, for triangle, T-R-I. Okay, what about for 4? Say that again, Don? No. Even though this is a square. But a quadrilateral, quad means 4 equal sides. Okay? So a quadrilateral, there's a lot of quadrilaterals. A rhombus is a quadrilateral. What else is there's like 3 or 4 different quadrilaterals that are other than a square. The one that looks like a diamond, rhombus and little kites, those can all be quadrilaterals. 4 equal sides. So we did triangle, we did quadra. What about 5? The number 5. You guys need to review your prefixes. Where does the United States military headquarters building, what's it called? What's it called? Pentagon. So penta means 5 because it's got 5 sides that are equal. Okay? So the pentagon, penta is 5. Hexa is 6. Okay? And I think 7 is septa. Okay? You guys need to review. 8 is octa, right? And those are the ones we use mostly. Now, these are not polygons. A circle is not a polygon because does it have a straight line? No, it does not. Circles are made with arcs. So each piece of a circle is an arc. There are no straight lines in a circle. That's why it's not a polygon. These shapes, even though they're closed, they are not any polygons because they're not straight lines. So the rules and regulations that we're going to be talking about in geometry deal with polygons, but we also will have some special rules for circles. But a circle is not a polygon. So if you ever get that question somewhere, remember, even though we study circles, they are not polygons because there's no straight line associated with a circle. Circles are created with arcs. Okay? All right, so a polygon is a closed figure with 3 or more sides. A triangle is a polygon with 3 sides. I want to go through some of these with you. Quadrilaterals have 4 sides. And a couple of quadrilaterals are squares, a rhombus, a kite, and there's one other one I can't think of right now. A solid means that the inside is filled in. Sometimes we have these squares and there's nothing filled in, and so that wouldn't be solid. Okay? Solids are usually 3-dimensional. You're always talking about the volume. You have the height, the length, and the width. And I call these prisms, and we'll talk about the volume of prisms a little bit later too. Now, let's talk about a couple of lines. I just talked to you a little bit about perpendicular lines. Those are lines that form what we call 90-degree angles. And you see this little square here? Anytime you have a little square like this inside the angle at the vertex, that means that this is a 90-degree angle, so it's perpendicular. So perpendicular lines mean they're intersecting lines, but they intersect at 90 degrees. And then parallel lines are lines that are equal distance from one another. The distance from here to here is the same as the distance from here to here. These are lines that never cross. Okay? So parallel lines cannot be crossing lines. And to be a true parallel line, it has to be equal distant from each other at given points. And this is how you spell equidistant. Okay? What's this thing? Who remembers what these are called? Say it again. Protractor. Protractor. We do not measure angles with rulers. Angles are measured with a protractor. And here is an illustration of a protractor. They look like a semicircle. They're half of a circle. There's a little hole, usually right here in the middle at this vertex where the line is twirling. And you put the vertex point of your angle there and line that angle up straight so that you can measure how big the angle is. Now, on a protractor, you always have 2 measures. You need to be able to classify angles so that you know what the correct measure is. So I'm going to teach you how to classify angles in about 1 minute. So I want everybody to just take their hands and shake them like this. And I usually just like to use air writing. I want to see everybody's hand shaking, okay? Now, some basic angles. Take your hand and go like this as straight as you can. Straight up and down. This is called a right angle because you're forming a 90-degree angle, perpendicular, right? We talked about 90-degree angles being in perpendicular lines. So this is a right angle, 90 degrees. Now, take that angle and go in a little bit. This is called an acute angle. Acute angles are less than 90 degrees. Okay, go back to your right angle. Now bend your right angle back as far as you can. Okay? When you have an angle that's between 90 degrees and 180, which would be a straight, if I was limber and I could take my hand and make it like a straight line all the way, which I cannot do, that would be called 180 degrees. But this is called obtuse. It's bigger than 90, but less than 180. So this is an obtuse angle. Okay? Can I see the obtuse angles? Yeah, acting like it hurts y'all. Okay? Now, when I do have a straight line like this is called 180 degrees because I basically have 90 and 90, which is 180. And this is a straight angle. Straight. Okay? Now, if I have a straight angle and I take my wrist and flip it like this, I have an angle that's created here. That angle is larger than 180 but less than 360, which is a circle. That angle is called reflex. Reflex. Okay, so let me see a right angle. Obtuse, acute, straight, reflex, right, straight, acute, obtuse, reflex. Give me a circle. Okay, you guys got angles just like that. Okay, now when you are reading a protractor, you're going to have an acute angle and an obtuse angle. Because notice it's just half of a circle. Now, unless you have a 90-degree angle, which is what kind of angle? Right. You have a right angle on this side and you have a right angle on this side. So you notice if you have your angle here and it goes straight up and down, it says 90, so you know you have a right angle. Both angles would be 90, okay? But I might have an angle that hits right here. If it's 135 degrees, what kind of angle is that? Obtuse. Okay? And if I have an angle that's 45 degrees, what kind of angle is that? Acute. Okay? And if I have an angle that totals 180, it's a straight line. What kind of angle is that? Straight. Okay? And you won't have this on the protractor, but you might have to figure it out. If you have an angle greater than 180 but less than 360, what's it called? What's it called? What's it called? Reflex. Okay? It's a reflex angle. Okay? We use a protractor to measure angles. I've already told you guys that. This angle is 120 degrees. What type of angle is it? No. Obtuse. Because look, it's going from here to here. So that's bigger than 90 degrees. So I want you to look at this protractor. Remember, when you put your angles in the protractor, you want to line it up right here. The vertex of that angle needs to be lined up right here. And wherever that angle hits, you're going to have two things to look at. There's going to be this angle and that angle. Well, this little one here we know is going to be acute, and the bigger one is going to be obtuse. So if you ever have to measure angles with a protractor, that's what you'll do. You'll line this vertex up by the little dot inside the circle before you start reading your angle. Now, what kind of angle is 90 degrees again? Right angle. Okay, so you guys already know these, so I can flash through them. We know that obtuse angles are greater than 90 degrees, but less than 180. We know acute angles are less than 90 degrees. Now, angles with a measure of 180 degrees form a straight line. So we call that what kind of angle? Straight angle. Okay, now, I'd like you to read this protractor. I've lined it up. The angle is, the way we label the angle is angle A, B, C. I could also say that this is angle C, B, A. So there's two ways I could say this angle. Notice I have a little angle symbol in front of it. I want you to read it as A, B, C. When you are looking at angles, do not forget this. The vertex must always be in the middle. So like I said, you can read this as A, B, C or C, B, A. B has to be in the middle because B is your vertex. So you want to read your angles correctly. What is the size of angle ABC? How much? 50. And how do you know it's 50 and not 130? Because the angle is acute. It is less than 90 degrees. I need to give you the acute measure, which is 50. 130 is obtuse, which would be this big angle here that doesn't have any labels. So from this 0 to here would be 130. That's not the angle I'm measuring. I'm measuring A, B, C, which is the inside angle to the right, and this angle is 50 degrees. That's how you'll read it. You guys got it? Okay. I agree with you. You say you got it? Then get up here and prove it. I've got several angles, and I want the answer to what size these angles are. Now, if I were you, I'd hurry up and get up out of my seat and pick one of the easy ones. Okay? Now, let's have you not write it on the board, but write it over here on the side. Because, let me put them up here, and you guys can just write down what they're equal to. Because that board does some really weird things. Yeah, if I were you, I'd come up here and get an easy one. That's for the, that's not, okay, you need to come over here and get one of the markers. Let me just write them up here, so. Okay, here's some more markers for those of you that just came up. I would grab one of the easy ones. Here you go. Okay, write the answers on the board because I don't want it on the smart board. That smart board keeps flashing up, and he didn't install it right. But you can, yeah, you can look at it and then put the answer up. and you're not going to be able to see it from your chair. So you need to get up out of your chair and come up and do a problem. And you guys can help each other out too. Y'all told me y'all know how to do it. I didn't ask for ROP, Rebecca. You need to look and see what's available there. Oh, is that A-O? I'm sorry. This is A-O-R, not A-Q-R. D-L-O-R. Are we almost done? Okay, let's just get the last one up here. We got two more, B-O-P and B-O-Q. B-O-P and B-O-Q. Now, once they get the answers up here, those of you that chose to sit in your seats need to verify the answers before I put them up there. We still need B-O-P and B-O-Q. You guys can help them out. Don't write it on the board. Yeah. Okay, everybody got it? Now, everybody's saying that AOP is 40. Is that 40 there or 60? I don't think that's 40. You guys, AOP is right here. AOP. And this is 50 here. 40 would be there. So it's really 60. Okay, so I got a problem with this first one. And when you are talking about, oh, somebody went back and corrected, because I noticed a couple of you didn't put your degrees there. When you're giving the answer to an angle problem, you need to say degrees. That's the units. Okay? So AOP is 60. Okay, now you guys said AOR is 90. Is that right? Yes. Okay. And you said that QOA is 120. QOA. Yeah, it looks like 120 to me. BOA. That's easy. What's BOA? 180, because it's a line, right? And then ROB. ROB is 90, okay? And BOP. 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 I got to come up here and look. 120, yeah. Looks like 120. And then the last one is BOQ. BOQ looks like it's 60, huh? Okay. All right. So you guys think that you could do this on today's practice test, on the pre-test and post-test? You will have to take a protractor with your mouse, line up the angle, and read it. Okay? Don't tell me that I don't love you. I got to give you guys sweet presents like that. Okay, so you will need to have some coordinating skills with the mouse, line up an angle, and measure it today on your assignments, on when you get on the computer, okay? I used to give people a couple of angles and measure them with a protractor, but my protractors would always disappear, so I no longer do that. I do it on the computer, so you're going to have to learn how to do it on the computer. Line up that vertex right where I told you where the dot is, and then read the protractor, okay? So you guys will have fun doing that. So these are the properties that we just went through real quick. Okay, if an angle measures less than 90 degrees, it's acute. If an angle measures 90 degrees, it's a right angle. If an angle measures more than 90 degrees but less than 180, it is obtuse. If it measures 180 on the dot, it is called a straight angle. And if it measures more than 180 but less than 360, which is a circle, it is called a reflex angle. Okay, so that's just a summary of what we did with angles just a few minutes ago. Now, I am going to teach you a couple of relationships that you're going to need for today's assignment. And you guys, once you learn this, don't forget it. Okay? Especially those of you that plan on taking the GED test, you need to know this stuff. What they'll do is they'll give you a road, and then they'll ask you an angle question about a road that's perpendicular. You guys need to know what these things are and what they mean, what the vocabulary means, okay? So, complementary angles, that's a special relationship between two or more angles. If you have two or more angles, and when you total them up, they equal exactly 90 degrees, they're complements of each other. So if I have an angle that's 40 degrees and an angle that's 50 degrees, I add them together, I get 90 degrees. They are complementary to one another. They are complements. Okay? That's one relationship you need to know. Supplementary angles. Anytime I have two or more angles, and when I total them up, I get exactly 180 degrees. Those are called supplementary angles. Okay? They are supplementary angles. That's their relationship. So you need to know the difference between supplementary, total 90 degrees. Supplementary that total 180 degrees, and complementary that's total 90 degrees. Okay? They have to total exactly those numbers to get those relationships. Now, what kind of lines are these? Parallel lines. Good. Somebody was paying attention. Remember, parallel lines are equal distance from one another. They never cross. So I've written parallel segments here, which illustrate like a road, and then I've written two parallel lines here. Now, a lot of times when we're doing these geometry problems, you're going to come across this word, congruent. Everybody say congruent. Congruent means the same size, the same. Because sometimes in geometry, your lines are, for all practical purposes, are the same. They might be minutely, tiny, itty-witty, bitty error of not being exactly the same. So mathematicians who are kind of crazy, and I can say that because I'm one, like to use a different word for that. But as far as I'm concerned, when you say congruent, it's the same as equal. For all practical purposes, it's equal. Okay? But they just like to use the word same. Is that somebody's phone I hear? Remember that complementary angles add up to 90 degrees, supplementary angles add up to 180 degrees, and all of the distances around a point create a special shape. And what's that shape? A circle. Circles total 360 degrees. So if I had a point for every measure outside the circle, the equal distance from that same point, I create a circle. Go back to what? Well, the last one was if I have a point that is equidistant all the way around, it totals 360. Yeah. I told you guys to look at page 2, 3, and 4 to get these definitions. Now, this is another special relationship, and one that is used in geometry all the time. Vertical angles. In order for you to have vertical angles, you have to have this condition: 2 crossing lines. No, I'm not talking about supplementary. I'm talking about vertical right now. In order to have vertical angles, you must have 2 crossing lines. Okay? Now, this is the relationship with vertical angles. Opposite angles are equal. I want everybody to say that. Opposite angles are equal. So, I've got 2 crossing lines here. This angle and this angle that are formed in these 2 crossing lines are equal. This angle and this angle are equal. Natalia says, oh, I see some supplementary lines. And she's right. This angle and this angle should be supplementary because they both form a line. This angle and that angle should be supplementary. This angle and that angle should be supplementary. And this angle and that angle should be supplementary. Okay? So she's absolutely right. There are some supplementary angles and vertical angles. But right now, I just want you to worry about the vertical angle relationship. Vertical angles means opposite angles are equal. Now, I just told you side-by-side angles are not equal. They may not be equal, especially in vertical angles. The only time you have side-by-side angles that are congruent is when you have perpendicular lines, because everything is 90, so everything is equal. But if you have adjacent angles, adjacent means side by side, the angles are side by side, they may or may not be supplementary. All we know is that they're side by side. Okay? And that's what an adjacent angle is. Also, another word that you might have for this that you might want to put in your packet, because you guys are going to use this other word, but it means the same as this, is linear. Linear is the same as side by side. So linear and adjacent angles and side by side all mean the same thing. Okay, and Violet, you were asking about the 360. So here's 360. We're going to use 360 here. If I have a circle and I carve out a segment, which is basically like a slice of pie, I take out 47 degrees. How much is this gray angle that's left? How would I figure that out? So that's right. And if I took the 360 and subtracted the 47, what would I get? 323? Are you sure about that? Take 360 and subtract 313. Yeah, you guys got 10 too much. So we need to know these particular properties in order to figure out missing angles. Guess what? You guys are going to be doing that today. You're going to need to use these properties we just talked about to figure out missing angles today. All right? I have a 90-degree angle, which is formed right here. But then I've got angle 1 and angle 2 that create it. So what kind of relationship am I showing you here? What is this relationship called? Complementary. So if I take away angle 2 and I tell you that angle 2 is 33 degrees, can you tell me what angle 1 is? 90 minus 33. And what would that be? Okay, great. So you need to know what relationship you're talking about. 57. They got a total 90 degrees, so 90 minus 33 is 57. So you can find the missing angles. What kind of relationship is shown here? You got a straight line. It's 180, but what is it called? Tell me the definition of what that's called. The relationship? Supplementary. Okay, so you are looking at a supplementary relationship. Okay? Now, if I take away 1 and tell you what it is, and I say that angle 1 is 75 degrees, what is angle 2? How much? And how did you get 105? 180 minus 75 gives me 105 degrees. Okay? So you need to look at your situation to see, is it complementary? Is it supplementary? Is it a circle? Or we had some other relationships. Is it vertical or is it adjacent or linear? So you have to look at those situations. Now, I'm telling you that you have a line. We've got 2 angles that we know. Tell me the missing angle right here if their relationship is supplementary. I can even just see that they're supplementary. What would the answer be for this missing angle here? How much? 100 and what? 109? 90? I think you need a little bit more there. Well, when you total these two, you guys, how much did you get? So what is 180 minus 77? What is 180 minus 77? It's not 100. Okay, finally. It's 103. Don't be guessing. You guys do the math. So when I total 35 and 42, I got 77. I take 180 and subtract 77 because it's supplementary, and I get 103. You're going to have to do some angle discovery today, all right, using these relationships. Okay, what relationship do you guys have here? What's this called? Vertical, that's right. You have crossing lines. That means that you have vertical angles. Now, I know that this angle right here is 100 degrees because it's labeled 100 degrees. How big is angle 2? How big is angle 2? How big is angle 2? 100 degrees. What's wrong with you guys? Opposite angles are equal. Right? So if this angle is 100 degrees, angle 2 is 100 degrees. And you're right, Natalia. Angle 1 would be 80 degrees, and so what's angle 3? 80. But first, if I have a vertical angle situation, I know the opposite angles are equal. That's the first thing I can label. Then I could do supplementary relationships with the side-by-side and the adjacent angles. So angle 1 would be 180 minus 100, which is 80. And that means that angle 3 is also 80 because the opposites are equal. So you can do it basically on the opposite side, or you could do it as adjacent. supplementary side to get these angles. So you guys have lots of ammunition to find these missing angles. Let's go to your packet. And you'll see that you have a pre-test and a post-test. Your pre-test is T517HMXZ. And your post-test is down on the bottom, GTANXMBA. If you have the textbook, you can do pages 209 through 224. That goes over geometry. I told you guys at the beginning of the lecture you need to look at pages 2, 3, and 4 for definitions. We went over these definitions already in the PowerPoint, so I'm not going to go over them again. Now on page 5 is your first activity, which is a vocabulary activity. I would like you and your table mate, based on the information in the PowerPoint and those 3 pages prior, page 2, 3, and 4, to match the second column, A through J, to the definitions 1 through 10. I'll give you guys about 5 minutes to do this matching. Do this with your table mates. Let's go over the answers to these vocabulary. You guys had enough time. Okay, what is 1? Adjacent angles. Didn't I tell you adjacent angles are side-by-side angles? So if they're side-by-side, then they're going to share a side, share a line. Yep, so the answer should be C. That's right. You should have picked C. What about complementary angles? G, yeah, they have to add up to 90, right? So G. What about congruent segments? What does congruent mean? Same. So they have to have the same length. So that would be H. Okay, where's the line at? B says a straight line that extends in one dimension. For number 4? You thought it was J? No, a flat surface. Isn't it a plane? J should be the plane. But what did you say, James? B? Mm-hmm. Okay, perimeter. What does perimeter mean? All sides added up. So you said which one it was? E is in easy. With distance around a figure, add up all those sides around. A plane we said was J, right? Okay, what about number 7? A straight edge. Nope. No, it's not B. We used B already. D is in dog. Yeah, I tell you guys this all the time. If you are taking a test, take your scratch paper and make it a straight edge. And anytime you need to draw a line or look at a line on a chart, use this as a ruler. Come on. Especially when you're reading charts and graphs. Use your edge as a ruler. Okay? Number 8. Supplementary angles. That one's easy, right? F. Number 9. The tip top of an angle. Didn't I just tell you the vertex is where the two rays meet and you have the angle? Come on, you guys. This is your vertex. Here's the angle. That's the top of the angle. Okay, what about, so that'll be A. What about the last one? You know what vertical angles are, right? I. Opposite angles are equal. Anytime you see vertical angles, you need to say opposite angles are equal. So if you missed any of those, you need to review all that vocabulary in your packet, okay? Now, on the next section that I kind of want to do with you is, remember when we did the air writing and we talked about the different types of angles? Excuse me. Well, let's actually classify them and label them. So, on number 1, I'm going to draw this part of the angle. What kind of angle would that be? Well, we classified it. Obtuse. And spelling counts. Spelling counts. On number 2, what kind of angle is that? Right angle. Okay, on number 3, what kind of angle is that? What kind? I want you to do this side of the angle here. You got to see what I do here. What kind of angle will it be? Obtuse, yes. So you got to watch what I do. Well, the number 4 is pretty easy, huh? Acute. Okay, what's number 5? That one's pretty easy. Acute. Number 6. Obtuse. Okay, number 7. Number 8. No, what did I call this? Straight. If you look at the instructions, it tells you which ones to do. Acute, obtuse, right, or straight. Reading the directions is half the battle. Okay, number 9. What am I going to get? Obtuse. Number 10. Acute. Number 11. Obtuse. Number 12. Obtuse. Number 13. Acute. And number 14. Obtuse. All right, now you don't really need to look at what I'm doing. You can just look at the size for 15 through 28. Look at the size of the angle based on its degree and then tell me what type of angle it is. 15 should be what? No. Acute, okay. What about 17? Right. What should 18 be? Oh, are you guys looking at 19? 19 is acute. But what about 18? Let's do these two. Obtuse. What about 16? Straight. And 20. Acute. So now let's just go left to right. What's 119 degrees is how much? What size? Obtuse. And 82 degrees would be acute. 160 degrees would be obtuse. 52 would be acute. 15 would be acute. 116 would be obtuse. And 96 would be obtuse. And 74 degrees would be acute. Okay, so those are the answers we got for the bottom of that page. Had you guys ever studied this before? Anybody? Yeah? Long time ago? All right, so we're done with the exercises on page 6. On page 7 at the top, you're going to use this figure to answer the questions here. Now, what is it that they want to know in problem number 1? They say, tell me what, you're going to classify the angle, but first you got to go find it. So we need to find angle EFB. Angle EF, where's B? B. Angle EFB is right here. Yeah, it looks obtuse to me. And then angle EFA. EFA, which is right here. What kind of angle is that? Acute. Then we have to go to angle EFD. 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 So there's two ways to write it. I'm gonna write it like this: EFD. Uh-oh, my screen went away. Because isn't this E and then F and then D? Because remember, I can do two sides to it. So what's EFD if it's this big long one here? Hello? That's more than 180, isn't it? What kind of angle is that, you guys? What kind of angle? Watch me. Reflex. It's reflex. It's bigger than 180. It's a reflex angle. Okay, and then the next angle is CFA. CFA. Which is right here. Yeah, that looks obtuse to me. That's number 4. Number 4 is obtuse. And then number 5, CFE. CFE is definitely straight. It's a line. Straight line. So those are the answers to page 7. I think you guys all get it. Then let's do page 8. It's almost break time, so page 8 will probably be the last one we'll do together. I'll do 1 or 2 on 8 and then 1 or 2 on the other pages, just so you guys know how to do them. So we're just going to classify whether these are linear or vertical. Remember, linear is the same as adjacent. I can't spell adjacent right. It's also side by side. When my daughter was doing her geometry class, they were just calling them side by side angles. I go, well, okay, that's right. So what would angle the relationship between A and B be here in number 1? No, this is vertical. Opposite angles. What about 2? Linear. They want you to pick either linear or vertical. But remember, linear is the same as adjacent or side by side. What would you do for number 3? What? Vertical. Opposite angles are equal. And what about number 4? Linear. Okay, so let's go to page 9. Page 9 is a review of complementary and supplementary relationships and vertical and linear relationships. Okay? So on page 10, if I tell you that angle B and angle P are complementary, and the measure of angle B is 32 degrees, what's angle P? I'm going to go 90 degrees minus 32 degrees equals, now why did I pick 90? Because they said complementary. Complementary angles total 90 degrees. So how much is that going to give me? 58. Then I'm going to go all the way down to number 13. Number 13 talks about supplementary. What is supplementary angles total? So when I see those key words, I might want to just put 180 there. So if the measure of angle M and the measure of angle G are supplementary, the measure of angle M is 62. What is angle G? We're going to take 180 and subtract 62. And how much did you say? 118 is what I get. So that's 2 examples on this page, and then let's just do 2 examples on the next page. On number 1, what would angle X be? What's the relationship here? It's linear, so I have to take 180 and subtract 71. What would I get? No, not 18. Isn't it 109? And be sure to put degree sign there, okay? Be sure to put a degree sign. Now, on number 3, what is the measure of angle X? It's vertical, so what's the measure of angle X? 108. Opposites are equal. Oops. On number 5, what's the measure of angle X? So, what's the measure of angle X? 133 degrees, okay? So, we've done 2 on that page. Page 12 at the top will be done the same way. Go to problem number 20. What's the measure of angle X? What would it be? Yeah. Measure of angle X is 112. Okay, and then at the bottom of page 12 are a few yum-yums. And you guys should be able to do those yum-yums. Go ahead and work those out with your table mates after we take a break. We need to take a 20-minute break. Or do you guys want to do this before we go on break? You need a break? Some people say they don't need one. That's because you came a little bit later, though, huh? Y'all need, a couple of y'all look like y'all need a break. But y'all came in late anyway. All right. When you come back from break, you and your table mates do the bottom of this page, and then we'll go over the answers. Okay? Or I might have you guys just look and check your answers and make sure you got them right. But go take a break for about 20 minutes. Everybody back before 10 o'clock. And then do this exercise with your table mates. And then check the answer.